Welcome back, class. So this video is mainly for the solution of the problem which I have uploaded to you, or which I have given to you, based on the unit 3 electrochemistry. Okay, so solution of numerical numerical problem of electrochemistry third. Okay, well, I have received many many students, they send me the solution of the questions which I have put to you, and most of you are able to answer the correct answer. Actually, they have given the correct solution for that questions, but I feel that there is some lacking, some sort of you know the basics, some sort of basic knowledge is missing, especially in sign notation. Okay, so that is why I think that it is very necessary to discuss all these questions. Although I can put or I can send to you the solution in image format also, but I thought that it's better to prepare a video for this solution, so that those who are not able to answer it properly or meaningfully, actually, and they may get some benefit. Okay, so let's start the discussion. We have 4 questions in this uh, video. So let's start the very first question. Question number 1. The question given to you is that the E naught values of MnO4 negative, Ce+4, and chlorine are 1.507, 1.61, and 1.358 volt respectively. Arrange these in order of arrange these in order of increasing strength of oxidizing agent. So this is the question, and let's start the discussion. The solution. See, question is given that you have to arrange these into increasing order of oxidizing nature. So increasing order of oxidizing nature, or we can say that it is a decreasing order of reducing agent, decreasing order of reducing agent. Okay, decreasing order of reducing agent. Okay, so uh, we have a values, we have given values, is the highest value which we have is of uh, this one is the highest one. Okay, and this value is for Ce+4. So Ce+4, that is 1.61 volt. Okay, sorry. And then we have second highest is this one. Okay, so this is for MnO4, MnO4 negative, and E naught value this given to you is 1.507. And third value, the least one, is the chlorine, that is 1.358. So Cl2 is 1.358. Now, so we know that the least value, the minimum value is for what? The minimum value is for reducing character. So that means the highest value is for what? Oxidizing agent. So here we have to put the strength of oxidizing agent. So this will be your order. Okay, this will be the highest oxidizing. Okay, and this will be the least reducing agent. Okay, so least reducing agent order or highest oxidizing agent order. So this is a very basic question, and maximum or not maximum, all of you are able to answer it correctly. Okay, now the second question. The given standard electrode potential, given standard electrode potential. So you have a values of some electrode potential. These are the K plus 2K. This is the reduction potential 2.93. Then magnesium plus 2 to magnesium, this is minus 2.73. Then Ag plus 2 Ag, this is 0.80 volt. Then we have Hg plus 2 to Hg, this is 0.79 volt. And then we have chromium Cr plus 3 to Cr, this is 0.74 volt. So these are the values you have given. The question is that arrange these metals into increasing order of reducing character. Increasing order of reducing character. Okay, so increasing order of reducing character, point to be noted. Reducing character, so reducing character is what? The highest capacity to reduce, and highest capacity means what? In this case you have to go for the least value of that particular matter. So in all given 5, the least value, the negative value is least one. So minus 2.93, that is the value of K plus and K plus K, that is given value is minus 2.93. So this is a very least value, so it will be highest uh, property of reducing character. Okay, then the second one is magnesium also. So magnesium plus 2 to magnesium. Okay, so although I'm not writing it correctly, it is a decreasing order. It will be here increasing order, but no worry, it's correct. I will correct it. 2.73. And then next is this 2 negative. Then the chromium is next negative. Okay, so Cr plus 3, Cr which has a value of E naught minus 7.4 volt. And then we have positive values, so these two positive values we have, and this value only difference is 0.01, but it still is a difference. So then we have a mercury, and finally silver. So Hg plus 2 Hg, which have value is 0.79, and then Ag plus 2 Ag, which have value of 0.80. So this is the actually decreasing order. Okay, so increasing order will be like this. You can put in this pattern also, although both is correct, but as per the question we have to go. So Hd 2 plus 2 Hg, then Cr plus 3 to Cr, then Mg plus 2 to Mg, and then K plus 2 K. Potassium is the highest one. So both is correct. So this is also your most of you are able to answer it correctly, so no problem with this. Now this is the page number 1, so I'm putting. Then the next question, question number 3 for you is that a cell contains two hydrogen. This is a very logical question actually. A cell contains two hydrogen. That means we have both side hydrogen. Okay, two hydrogen electrode, and the negative electrode is in contact with the negative electrode, means the left hand side electrode. the negative the negative electrode is in contact with what? Is in contact with a solution of 10 to power minus 6 m H ion. Okay, H ion. The EMF, the EMF, the EMF of the cell is, it is always positive, so the EMF of cell is 0.118 volt at room temperature, that is 25 degrees Celsius. Calculate the concentration. Calculate the concentration of hydrogen ion at the positive means we are talking about the right hand side. Okay, uh, positive electrode. So this is the question of hydrogen electrode actually. So first we need to write the cell. Okay, the cell may be written as, the cell may be written as, so here at the negative electrode, this is contact with 10 to the power minus 6 molar H ion. Okay, so this is the negative electrode, the right hand side, H2 to H plus ion, which has concentration is 10 to the power minus 6 molar, and with this salt bridge, the right hand side, which concentration we don't know. Okay, so here is A2, you can write, and this you can write A1, although we know that, but for simple manner. Okay, and this will be contact to hydrogen platinum. Okay, so this is your question. You need to find out concentration of this one. Okay, now this is the cell. So let's write the equation, cell equation first. So left hand side, that means this one hydrogen, this will converted into H plus by and the activity is A1 with release of electron. And then we have a right hand side, so this H plus which has activity A2 with getting one electron converted into hydrogen. So the overall will be what? This will be cancelled out, these two will be cancelled out. So this is uh, H plus A2, this is A2, and 2 H plus A1. Okay, so this is your final cell equation, H plus, because based on this cell equation we will apply the Nernst equation. Okay, so A1 upon A2 will be your Nernst equation. A1 upon A2, you can see it very, because many time you are in doubt actually. So this is H2 to H plus A1. Okay, left hand side, right hand side is H plus A2 to H2, and here we are balancing the equation by half. Okay, so no need to worry about this. This is the half and this is the half. Okay, so the equation is balanced with single electron. So next we'll apply the Nernst equation. So let's moving ahead, the second page. Okay, now the Nernst equation, let's apply the Nernst equation. So applying Nernst equation, okay. So Nernst equation is what? E equals to E naught, okay. E H, sorry, E equals to E naught minus 0.059, and here we have only one electron, so no need to write that value. And log H plus H plus, and as I told you, this is what we have, A1, okay, A1 upon A2. So here I am writing H plus A1 and H plus A2. Okay, this is very important to understand. Okay, then we will write the values. So this you have given in the question. Here is the question. So this is value you have given in the question. The EMF of the cell is 0.118. So here 0.118. This you all know that E naught is always 0 in case of hydrogen, so this is 0. And then 0.0591 log A1 is means what? Activity of H ion. So here A1 is given to you is 10 to the power minus 6, and this you need to identify. So here 10 to the power minus 6 upon A2, okay. And then here what we'll do, that here is the minus sign, so 0, so this is 0.118 and divided by 0.059, okay. This will be writing in this side negative, and this will be log 10 to power minus 6 A2. So this will be cancelled out by twice. This is exactly twice of this, so this is minus 2 equals to log 10 to power minus 6 A2. And if you convert this value, this will become into 10 to the power 2. So this is minus 10 to the power 2, 10 to the minus 6, and A2. So A2 equals to what? A2 equals to 10 to the power minus 6, 10 to the power minus 2. This will give 10 to the power minus 4. So your answer will be concentration of this cell, sorry, this side ion will be 10 to the power minus 4, okay. So this is the answer, and maximum you have done it correctly. Now even you can cross check it also. There is a way to cross check is also, okay. So you know that if you go for this equation, if you go for this equation, here I am writing, so this is non value, okay. But if you put this value, this should come, this EMF of the cell should come. So E equals to E naught minus 0.0591 and log A1 upon A2, okay. So here is the value is 0 minus 0.0591 log A1 is what? A1 is the value which you know that it is 10 to the power minus 6, and A2 which we have 10 to the power minus 4. So this will give you negative 0.0591 log, this will goes to opposite side, 10 to the power plus 4, okay. And this will give you 10 to the power minus 2, okay. And this minus will comes to this side, so this will become plus, and 2 into 0.0591 log 10. Log 10 value is 1, and multiplying by this will give you 0.118 volt. So this is the answer which is here given. So this is in this way you can easily cross check your answer of this question. Okay, moving ahead, the last question for the discussion, and this is very important question. Most of you are able to answer this question, no doubt about that. But the way you solve this problem, this is quite interesting for me also. and that is why I'm here to prepare this video because of this question only. Okay, although you are able to find the correct answer, no doubt about that. It seems that you all know the answer, but the way you solve the problem, this is quite interesting, and that is why uh, you should understand the basics, the sign notations of the electrochemistry concept. Okay, so here I'm giving you a solution. I'm not saying that these are the only way to solve this problem, but without violating the basics of electrochemistry. Okay, you can approach any method, but you cannot violate the uh, basics of the sign notation. Okay, so this is very important question. The EMF of a cell corresponding to this reaction, this is the reaction for you. This is the reaction I'm underlying here. Zn solid plus 2h plus Zn plus 2 h2 is 0.28 volt. Okay, at room temperature 25 degrees Celsius. Here you have to calculate the pH of the solution, pH of the solution uh, of hydrogen electrode, of hydrogen electrode. Okay, so there are several other values you have given. First is E naught Zn plus 2 to Zn. You should now you should memorize this value, because this is we have used commonly, very oftenly we have used this. Okay, and the second is H plus to H2, and this is 0. Okay, so this is the question for you now. Let's start the discussion of this question. First you have to write the cell. So this is the reactions of this is the cell reaction, left hand side reaction and the right hand side reaction. So if you go for the overall reaction, this is Zn solid and Zn plus 2 with hydrogen. So this is in aqueous form, this is in aqueous form. Okay, so this upon this as per the Nernst equation, and you have given values of this given you value you have given. So let's apply the Nernst equation. Applying Nernst equation equals to E naught minus 0.059. See, one point you should understand. We have two electron here, so we will balance this hydrogen by twice instead of half. If you are balancing with a half, this you need to change. So there is no need to change, because this is two electrons, so you can easily write in this way also. But at the other end, if you see, like in this previous, we have balanced it with half, because we have only one electron. Okay, so this you need to take care that it depends on the electron. This is the two electrons, so we have to balance it with the two. Okay, so we have value of n is 2, and then log Zn plus 2 and h plus, and this h plus is what, this h plus has two coefficient, so this will become in the power. Okay, this this value we have to find out also, because this is not a value 0. This you have given, I'm writing here uh, this E you have given here, it is 0.28. Okay, and this value you have given. So we'll find out the value of E cell first. Okay, E naught equals to what? E naught equals to, this is the right hand side equation, this is the left hand side equation. Okay, so E naught H plus 2H2 minus E naught Zn plus 2 Zn. Okay, so this is 0 and this you have given is minus, so minus 0.76, this will give plus 0.76 volt. So the value of E is 0.76. Let's apply this equation, values in this equation. So here is the value, third page. So we have a values 0.28, 0.76, this is in plus, 0.0592 log, and Zn plus 2 to H plus twice. So 0.28 minus 0.76, this is minus 0.592 log, this value you have given is 0.1. Okay, as per the cell. So minus 0.48, this twice become this side, and minus 0.059. Here we have log 0.1 upon H plus 2. This after solution will get 16.27 log 0.1 minus 2 log H plus. Okay, this you can change. 16.27, this is log 1 upon 10 minus 2 log H plus. 16.27 log 1 minus log 10 2 log H plus. Log 1 value is 0, log 1 value is 0, log 10 value is minus 1, and minus 2 log H plus. So minus 1 will come this side. So 16.27 plus 1 equals to minus 2 log H plus. Minus log H plus is what? pH. So this is 17.27 divided by 2 equals to minus log H plus, and this is what? pH. So pH equals to 8.63 if you divide it. You all are done this question, no doubt about that, but I somewhere I found that the value of this is negative always, and there are so many sign notation mistakes. I'm not saying the problem with the answer, sign notation mistakes. Okay, so I hope this video help you in order to solve this problem, and I'm sorry that we have lots of interruption in background. Okay, so please ignore this. Today I'm not feeling well, but this is the solution of the problems which I have uploaded to you. Thank you so much. This is the numerical which I have asked to you. Let's start the discussion on this numerical. So this is the very simple one. If you go for the PBI2, this will give you PB plus 2 and 2I. Okay, you have to find out the concentration of each ion. Now I'll go for the initial value, then the uh, change, what change occurs, and then the equilibrium. Okay, so here the value will be 0 and 0. Here we have no idea, so we'll write x. Here you should remember, this is what you need to understand. Here we have set 2 coefficients, so this will be 2x, and this is again x and 2x. So now the KSP, so KSP is what? PB plus 2 and iodine twice. Okay, and this you have given to 7.9 into 10 to power minus 9. This is nothing but x, and this is 2x. This is what? 2x. So 2x power 2. So all this is what? 7.9 10 to power 9. This will be 4x cube, and this will give you 7.9 10 to power minus 9 divided by 4, and this will give you root 3 equals to x. So here the value of x is what? If you go for the calculation, the value of x will be 2.6 10 to power 9. You can check this value. No, I'm not sure about this. You can check this. Okay, especially I'm talking about the pattern only. So this is the lead plus 2, and for iodine we have twice, so the value of twice of this will be value of the iodine ion. So this is only thing you need to remember, this one. Okay, as this value will change, of course this value will change. So this is how the numerical problem will be solved. And then the next one, that is again very simple one. So what you need to write is that Ca is in plus 2 form, so we have 5, so this will be 5. And then we have PO4, that is in 3 negative, and we have thrice PO4, so this will be in thrice form. And then OH minus, we have only one OH, so this is how the soluble product will be written in this case. Okay, so I think both the numericals are simple one. This you need to correct. Okay, 7.9 10 to the minus 4. You just solve this. Okay, thank you so much for your watching.